Assalamu alaikum warahmatullahi wabarakatuh. Welcome to our project-based learning with the proposed title CNC Automation Upgrade with and Production Scheduling System for Manufacturing Workshop at Padang Besar Industrial Area in Perlis, presented by Group 6 with group members of Muhammad Firoz bin Muhammad Azhari, Tan Jin Hyun, myself Yunus Ali Omar Ballajam, and Muhammad Nabil Daniel bin Jasmi and Muhammad Nazbi Asfar bin Saiful Bahri. So we start with the introduction. So the proposed CNC automation upgrade project is integrated with the digital production scheduling system and implementation at Padang Besar Industrial Area, Perlis, and it aims to reduce the machine idle time and also to reduce the setup delays and also to reduce the manual handling inefficiencies. And its uses focuses on automatic loading and unloading, basic machine monitoring sensors, and standardized fixtures, and also digital scheduling with finite capacity planning. And the expected benefits is higher machine utilization, lower production costs, improved on-time delivery, and also better decision making using real-time data. And the target users are SME, manufacturing workshops, or companies, CNC and also CNC operators, and production planners. And next, for the project objectives, there are three main objectives. The number one is to improve the machining efficiency by reducing the machine idle time, setup time, and also to reduce the manual handling in CNC operations, since it takes longer than it should be. And for the second point, is to reduce the overall production cost through CNC automation upgrades. And lastly, is to enhance the competitiveness and sustainability of manufacturing workshops in Perlis.
Hello, Assalamualaikum. My name is Muhammad Nabil Daniel bin Jasmi. My matrix number is 2213100972. Okay, now I will present about the project background, which is our project is CNC automation system. Okay, the current situation, which is many SME workshops still use basic CNC machines, and manual production planning is widely practiced, lead to high setup time and machine idle time. Okay, the problem statement is inefficient job sequencing and poor scheduling, increased operation costs and labor dependency, difficulty meeting delivery deadlines, and low utilization of CNC machine capacity. And our project is to propose direction, which is to integrate CNC automation upgrades, implements digital production scheduling system, use real-time machine data for efficient workflow, and last one is to improve productivity, cost efficiency, and competitiveness. Okay, next for the project scope, which is to analyze, study existing CNC machine and workflow, identify setup time, ideal time, and scheduling issues, reviewing current production planning methods. And our design and development, which is to design CNC automation upgrades, develop digital production scheduling system, integrate machine monitoring and data flow. For implementation and evaluation, which is to implement automation and scheduling solution, evaluate productivity, efficiency, and machine utilization. And the last one, which is to validate improvement in production performance. Okay, for the next slide, which is our project site, which is we choose the Padang Besar Industrial Area, Perlis, Malaysia, is our project site. And this site is selected due to the high concentration of SME CNC workshops, predominantly manual production planning, and last one, which is to set suitable environment to evaluate automation and scheduling improvement. Okay, next slide, which is project scheduling flow, which is we need to go through to realize our project, which is CNC automation system. There are four flow, which is the first one is define project activities, which is work breakdown structure. And the second one is just the schedule tasks using Gantt chart. The third one is identify the critical paths, and the last one is the construct project milestone. for our
Okay, for
projects.
the next slide
Is the project Gantt chart. As you can see, there are 10 tasks distributed by our group, which is divided uh, divided by our project manager. And the task distribute is project overview, product identification and scheduling, resource allocation and risk assessment, mitigation, comprehensive cost estimation with detailed breakdown, cash flow and financial analysis, budget feasibility and sensitivity analysis, market value and innovation differentiation, business feasibility and revenue potential, summarize the key finding and draw a conclusion, submission and standardize proposal and presentation for our projects. Okay, next, for the next slide is work breakdown structure that we construct by our project manager. There are 10 activity that we need to implement in our project, which is project initiation and data collection, feasibility and risk analysis, system requirement definition, CNC automation design, product scheduling, system design, IT and network infrastructure design, software development and CNC integration, hardware installation and network setup, systems testing and performance evaluation. And the last one is to implementation, training and final report of our project in the industry. Okay, for the next slide, which is our project monitoring through critical path methods. As you can see, the diagram shows the critical path methods, which is the workflow for our CNC automation system. And if we look at the below, there are critical paths, which is for, for the task A, task B, task C, task D, task G, task I, and task J, which is there are no there are no slack, which is it can affect the whole project if don't come out with the due date. Okay, for the next slide is a project milestone. There are 7 milestones that our project need to implement in the system, which is project initiation, data collection complete, feasibility and risk analysis, technical and cost feasibility approved, and then the system requirement, functional and non-functional requirement finalized. And next is the system design, which is design the CNC automation and scheduling design. For the next is the development and installation, software development and hardware installation. And then the next is the testing and evaluation for system testing and performance evaluation. And the last one is the implementation and submission due to the user training and final report.
Okay, now I'm going to talk about risk identification. Risk identification is the first stage of the risk management process. It involves systematically assessing potential risks that may affect your project objective. Risks are identified based on project scope, technical requirements, resources, and operational environment. Early identification enables proactive planning and prevent major impacts on cost, schedule, and performance. Uh, there is 6 risk management process. First, assessing your risk. Second, prioritizing your risk. Third, figuring out your risk profile. Then choosing your risk strategies. Uh, Fifth, executing your risk strategies. And the last one is measuring residual risk. Then we move on to the risk analysis and control. Uh, as you can see on the table, there's a risk category, and then potential impact and control the measure. The first one is technical risk. Potential impact is high. How to control it is by conduct a leak system testing, compatibility, validation between CNC machines and automation. Then goes to financial risk. Potential impact is medium. Uh, then to control it is by allocate budget contingency and perform cost monitoring throughout the project. Then goes on to operational risk. The same goes to financial risk. The potential impact is medium. To control it by implement phased installation to minimize production disruption during commissioning. Then the last one is human risk. The potential impact is low to medium. To control it by provide operator training and technical support to improve system acceptance.
For this slide, I'll explain the cost estimation of the project. The total estimated project cost is 42,500 from activity H to J. This activity includes equipment, labor, materials, software, utilities, training, and overheads. From the analysis, direct costs make up the largest portion of the budget at 34,950, while the indirect costs total at 7,550. This shows that most of the investment is focused on the technical implementation such as automation hardware, CNC integration software, and engineering labor. In terms of cost types, fixed costs amount to 23,450, mainly from the equipment, software, licenses, and training. Variable costs at total 19,050, driven by labor and material usage across different places of the project. Overall, the cost structure support the both system development and long-term implementation requirement. Moving on to the payback period, the project requires an initial investment of 42,500. The system is proposed under a rental-based model with an annual operating and maintenance cost of 15,000 per unit. This includes software updates, IT utilities, preventive maintenance, training, and administrative costs. With a 20% profit margin, the annual rental price is calculated as 28,140 per year. After deducting operating costs, the annual net cash inflow is 10 approximately 13,140. Using this value, the payback period is calculated as approximately 3.23 years. This indicates that the project is able to recover its initial investment within a reasonable time frame. For CNC automation projects is the break-even analysis. The project has a fixed cost of 23,450 and a variable cost of 19,050 per unit, while the rental price per unit is 28,150. This results in contribution margin of 9,090 per unit. Applying the break-even formula, the break-even point approximately 2.58 units, which is partially rounded to 3 units rented. Below this level, total cost exceed revenue and the project operates at a loss. Above this level, the project begins to generate profit. This low break-even point reflects strong financial feasibility and relatively low investment risk. I will explain the internal rate of return or IRR. The IRR represents the discount rate at which the net present value of the project becomes zero. In this analysis, IRR is calculated using linear interpolation between discount rate of 15% and 30%, where the present worth change from positive to negative. The calculated IRR is 27.5%. When compared with the minimum attractive rate of return of 20%, the IRR is significantly higher. This shows that the project is capable of generating returns above the required benchmark and has a good margin to accommodate risk and uncertainty. For this slide, I will
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fidaus. For this part, I will explain the budget feasibility, sensitivity analysis, and the market and business potential of our project. First, budget feasibility show that our proposed budget of 42,500 is not only sufficient to implement the system but also economically sound. The cost cover all the direct and indirect expenses such as hardware, software, labor, training, and integration. From the financial analysis, the project can cover its initial investment within about 3.23 years, reach a break-even at only 3 units rented, and generate strong long-term returns. This supported by positive features of RM 38,310 and an IRR of 27.5%, which is higher than the MARR of 20%. Therefore, the project is financially viable and suitable for the real industry implementation. Next, its sensitivity and risk analysis in costing show that the project is financially resilient. Even if there is an increase in major cost component, the impact on feasibility is small. For example, a 10% increase in material cost only rise the total project cost from 40,500 to 43,800 and slightly increase the payback period from 3.23 to 3.3 years. This proves that the project remains stable and profitable under reasonable cost fluctuation. In addition, potential risks such as hardware replacement, software integration, delay, higher labor costs, installation downtime, and training inefficiencies can be controlled through contingency planning, early procurement, modular implementation, continuous training, and improvement and progressive testing. For market potential, this system is designed for small and medium enterprises that still use basic CNC and manual scheduling. This workshop faced low productivity due to inefficient planning. Our system provides a practical and affordable solution that improves machine utilization and workflow efficiency without requiring expensive full-scale automation. It also fills the gap between costly industrial automation system and simple standalone scheduling software by integrating automation with real production planning. Furthermore, by using real-time machine data, the system allows dynamic job sequencing and reduce machine idle time. This creates a more stable and predictable production flow, helping workshop meet the delivery deadlines and improves reliability. The modular design also increases market acceptance because workshop can adopt the system gradually, starting with basic function and expanding later according to their budget and confidence. Finally, in terms of business potential, the rental-based model with a 20% profit margin ensures sustainability for the provider and affordability for user. With a payback period of 3.23 years and an IRR of 27.5%. The project showed the strong long-term profitability. The system reduced operating costs by minimizing idle time, setup delay, and inefficiencies, allow workshop to increase output using existing resources. Automation and monitoring also reduce human error, rework, and material waste, which improve product quality and lower hidden production costs. At the same time, manager can better decision because the system provide real-time visibility of machine availability, workload distribution, and production progress. This shift production planning from experience-based decision to the data-driven management, making the system not only a technical tool but also a strategic support for business growth and future investment. That's all for me. Thank you.
And lastly, for the conclusion, in terms of the operational optimization, by integrating real-time machine data with the digital scheduling, the project successfully eliminate the manual planning inefficiencies and reduce the machine ideal time and also the setup delays. In terms of the technical feasibility, the project is validated through management tools like the work breakdown structure (WBS) and also the critical path method (CPM), and that's proved that it's ready for the real world industrial use. In terms of the economy resilience, on 42.5 thousand investment ringgit investment, the project achieves an IRR of 27.5%, which is above the MARR 20%, with a rapid of 3.23-year payback period and a low break even of 3 units. And in terms of last point is the innovative planning and smarter and faster. The model design helps Perlis SME, small companies and medium companies transitions to Industrial 4.0 by replacing guesswork or basic data collection with data-driven insight to improve resource control and sustainability and fast decision making. So the proposed CNC automation and digital scheduling system transforms the traditional SME workshop into intelligent, data-driven environments by integrating real-time monitoring and engineering framework like WBS and CPM. This solution eliminates the ideal times and setup delays, ensuring the transition that is both technically feasible and practically implement. So as for financial, this model ensures the rapid cost recovery and long-term sustainability. And ultimately, this model solution bridges the gap between the basic tools and the full-scale automation for SME, small and medium companies in Perlis. It reduces the financial risk while empowering the small workshops to embrace Industry 4.0 by replacing experience-based judgment with a reliable data-driven insight. Thank you. Thanks to